Now our topic is transistor as a device. So first of all we have to form a transistor. See, this transistor again NPN transistor, we have base, emitter and collector. This is our emitter, this is collector and this is base. Similarly, according to our previous circuit, we have to draw here 1 milliampere, so it is IB. Further, here we are having VBE, this we have to join with grounding. Further, here one resistance will be there and one, now we have to connect battery. So this is forward bias NP and this is P, so P should be connected with positive and negative. So this is our VBB, correct? This is R1. Okay, now further we have to connect again similar to here IC, which is in milliampere. Now further we have one voltmeter which is called VCE. Further one resistance will be there R2, and now battery. See, this is collector NP and N should be connected with positive. So this is the whole circuit and it is called VCC, right? So this is our whole circuit. See, this is IB in this direction, IC is in this direction and IE, correct? Now this is NPN resistance. So NPN resistance, current towards in this direction, right? Now we know that IE is equal to IB plus IC, correct? So here transistor as a device, now we have to apply Kirchhoff's law, Kirchhoff's second law to this input characteristic. So by applying that law, we are getting VBB is equal to VBE plus IBRB. So this is for input. This is our first equation. So that is VBE. VBE is our input. So that's why here one correction is here, VBB and here VB. So that is our input. Now for output, VCE is equal to VCC minus ICR. ICR2. Here I have to write R1 because our resistance is R1. Okay. So now by these formulas, VBE is our input voltage, so I have to write VI instead of VBE is equal to VBB plus IBR1. Similarly here, V output is equal to VCC minus ICRL R2, correct? That is our ICR2. Now input and output, we are having both the voltages. Now if I am drawing here one characteristic which is of VO versus VI, means output versus input, what we get here, we are getting here like this graph. So this, between these two graphs is called active region, active state, or we can say this is cutoff and this is called saturation. So we are having basically three characteristics of output and input voltages, right? Cutoff, active region and saturation region. Now see, from this graph we can observe that when VO is high, VI is low. This is first observation. Second observation, vice versa, VI is high, then VO is low, right? So this is like switch, one is off, another is on, another is off, one is on, like that, right? So to form this circuit, we have this active region. So a circuit is not longer time in active region. It is for a very short period of time, very tiny time. So very short period of time this circuit will be in active region. Otherwise it will be in cutoff region or saturation region. Either it is VO high, VI low, VI high, VO low, right? That's a transistor as a device. In same circuit, now we have to study about transistor as an amplifier. Now transistor as an amplifier, see, transistor as a switch, we are using that cutoff and saturation region. But for this amplifier circuit, we have to use active region of this circuit. Now for active region of this circuit, see here we are having two equations. In these two equations, if you want to find voltage gain, so voltage gain AV is equal to change in output voltage upon change in input voltage, right? Change in output voltage is this, but we don't have change here. So we don't have change here, that's why VCC will be 0, VBB will be also 0 because no change in VBB also. So now we are left with minus IC, means delta IC R2 upon IB, delta IB R1. So this equation is known as voltage gain, but see now minus, what is IC upon IB? It is beta AC, and similar R2 upon R1. So always for an amplifier acts in only active region, and voltage gain of that amplifier circuit is this equation, right?